Hello and welcome to our review of right triangle trigonometry and extension to the unit circle. First, let's start with some right triangle basics. In fact, even some triangle basics. All of the angles in a triangle add up to 180 degrees. And that's true for all triangles. In a right triangle, we have a right angle here marked with a square. That is 90 degrees. That's what makes it a right triangle. It has a 90-degree or square angle, which means that the sum of the other two angles must be 180 minus 90, which is 90 degrees. We also have some important names for the sides of a right triangle, particularly the side that is opposite the right angle. Side C here is called the hypotenuse. It's really important to correctly identify the hypotenuse of right triangles if you want to start working with them. The other two sides we call legs. So we have two legs. We have the Pythagorean theorem that tells us that if we square the length of each side and add them together, that will equal the length of the hypotenuse squared. That's our Pythagorean theorem, and we're going to use that as we develop some of our right triangle trigonometric ideas. So next we're going to take a look at the basics of right triangle trigonometry. Once again, we're looking at a right triangle, and we have the hypotenuse labeled across from our right angle here as the hypotenuse. We've also labeled an angle X here, and we've labeled the side that is next to angle X, the first leg here, as the adjacent because it's next to, which is what adjacent means, next to the angle that we're working with. The side that is opposite the angle we're working with is called the opposite side, and so we're calling the adjacent A and the opposite O. This will allow us to develop our right triangle definitions for our basic trig functions, or what you might recall as SO, CA, TOA. The sine of angle X is defined to be the length of the side opposite divided by the hypotenuse. So we have SO for sine. The cosine of angle X is defined to be the side adjacent divided by the hypotenuse. So it's the length of the adjacent side divided by the hypotenuse. Or CA, cosine, is adjacent over hypotenuse. And the tangent of angle X is defined to be the length of the side opposite divided by the length of the side adjacent. So that is our basic definitions here, our SO, CA, TOA, for our trig functions in right triangles. And what we're really looking to do in this lesson is take this review from geometry. Remember how to use this besides just finding the sine, cosine, and tangent if I'm given the lengths of the sides, and then extend that to our unit circle. So let's take a look at finding the length of the sides if we know the angle and the hypotenuse. So if I know the length of this angle, which we're calling A here, but I often call theta in class, and I know the length of this side C, then I can use the sine function to find the length of side A, or the cosine function to find the length of side B. Let's consider why this is. I know that sine A is equal to the length of side A over the length of side C, the opposite over the hypotenuse. So here's my hypotenuse, here's my side opposite, and again here's my side adjacent for completeness. Well, that means that if I have angle A I can use a sine function. I can treat this as a number because it is a number. If a is a number and I put sine a into my calculator, I get out a number. So if I want to find the length of side a here in this, then I need to multiply this equation by c, and I get c sine of angle A is equal to the length of side A. So if I have numbers, if the length of my hypotenuse is 1 and the measure of angle A is 45 degrees, then I have 1 times the sine of 45 is equal to the length of side A. And the sine of 45, which you can find with your calculator for an approximation, or as we'll learn later, this is equal to the square root of 2 over 2. So I have 1 times the square root of 2 over 2 equals A, and I know then that the length of side A is the square root of 2 over 2. So I can use a similar line of reasoning to find the length of side B. The cosine of angle A is the adjacent, which is B, over the hypotenuse, which is C. So if I multiply by the hypotenuse, then I get C cosine A is equal to side B. Since 45-degree angles give me an isosceles right triangle, because the sum of the measures of these angles must be 180, and this angle's 90, and this angle's 45, that leaves 45 for angle B, and the adjacent side is also going to have a length of the square root of 2 over 2. But if I had not used an isosceles right triangle, we'd get a different value for our cosine than we got for our sine, since the side lengths would be different. So we just treat sine of an angle or cosine of an angle as a number and just solve this sign definition equation so that we can find the length of one of the sides. In the next video, we'll extend this to our special right triangles and then to our unit circle.